Roman tunnels projected were carefully planned and carried out. The length of time it took to construct a tunnel depended on the method being used and the type of rock being excavated. The canal construction method was usually faster than the counter excavation method as it was more straightforward. This was because the mountain could be excavated not only from the tunnel mouths but also from shafts. The type of rock could also influence construction time. When the rock was hard, the Roman employed a technique called fire quenching, which consisted of heating the rock with fire and then suddenly cooling it with cold water so that it would crack. Progress through hard rock could be very slow, and it was not uncommon for tunnels to take years, if not decades, to build to be built. Construction marks left on a Roman tunnel in Bologna show that the rate of advance through solid rock was 30 centimeters per day. In contrast, the rate of advance of Claudius tunnel can be calculated at 1.4 meters per day. Most tunnels had inscriptions showing the name of patrons who ordered construction and sometimes the name of architect. For example, the 1.4-kilometer Sevlik Tunnel in Turkey, built to divert the flood water threatening the harbor of ancient city of Seleucia, Pyria, had inscriptions on the entrance still visible today that also indicate that the tunnel was started in 69th century and was completed in 81st century. Changing in reading habits. What are implications of the way we read today? Look around on your next plane trip. The iPad is the new pacifier for babies and toddlers. Younger school aged children read stories on smartphones. Older kids don't read at all but hunch over video games. Parents and other passengers read on tablets or skim a flotilla of emails and news feeds. Unbeknown to most of us, an invisible, game changing transformation links everyone in this picture. The neuronal circuit that underlies the brain's ability to read it subtly, rapidly changing, and this has implications for everyone from the pre-reading toddler to expert adult. As worker in neurosciences indicates, the acquisition of literacy necessitated a new circuit in our species' brain more than 6,000 years ago. That circuit evolved from a very high mechanism for decoding basic information, like the number of goats in one's herd, to the present highly elaborated elaborated reading brain. My research depicts how the present reading brain enables the development of some of our most important intellectual and affective processes: internalized knowledge, analogical reasoning, and interference and inference, perspective talking and empathic critical analysis, and the generation of insight. Research research surfacing in many parts of the world now cautions that each of these essential deep reading processes may be under threat as we move into digital based model modes of reading. This is not simple binary issues of print versus digital reading and technological innovations. As MIT scholar Sherry Turkle has written, we do not are a society when we innovate, but when we ignore what we disrupt or diminish while innovating. In this hinge moment between print and digital cultures, society need to that confront what is diminishing in the expert reading circuit, what our children and older students are not developing, and what we can do about it.